second is the momentum equation, and all the quantities used here are non-dimensionless whether in the number of the flow. Here are some equations for the dynamics of particles, and first equation represents the total velocity of the particles, which is the summation of the local fluid velocity and summation of the velocity with which we inject the particles in the fluid, and this is the V is the local orientation, and this term shows the reorientation of the particles. The first term is due to the reorientation of the particle due to being bottom heavy, and the second term is due to the presence of vorticity, and the third term is due to the reorientation in the due to the rate of strain in the shear flow. And here alpha naught is the eccentricity. For the spherical particles we have eccentricity equal to 0, and for elongated particle or rod-like particle we have eccentricity equal to 1, and in between we have for ellipsoid particles. And this is the gravitational torque, and here as we can see that h is the distance between the center of gravity and the center of mass, and this is the viscous torque, and here omega represents the angular velocity of the streamers, and the summation this is the total torque act on the particle, and for equilibrium the summation of both the types should be equal to 0. We use three different models for our simulations. First we have the horizontal channel when the gravity is acting in the negative y direction, and for the second case we have gravity in opposite to the direction of the flow, and for the third case we have these two are the vertical channels, and here we have the gravity in the direction of the fluid. And the boundary conditions we have a periodic boundary condition in streamers and the spanwise direction, and mostly boundary conditions on the wall, and also we have elastic particle detection. When particles collide with the walls, they come back with the same velocity. And here is the table for different parameters we use in our simulations. First is the channel dimension. Here Lx, Ly and Lz is the dimension of channel in the streamwise, spanwise and the spanwise direction. And here we have different resolutions. For turbulent case we have this resolution, and Nx, Ny and Nz is the resolution in the streamwise, spanwise and in the vertical direction. And here we have eccentricity, and which I showed in the particle dynamic equation with alpha naught. And for the spherical, as I said, we have 0 eccentricity, and for ellipsoid particles we use 0.8. And when we inject the particles in the fluid, we use velocity equal to 0.02, and the Reynolds number we use for the turbulent 4200, and for the laminar case we use 1000, and the friction Reynolds number we use 180 and 44.72 for the laminar case, and the number of particles we use are around 500,000, and this G represents the gyro axis, which is equal to 1/2b. And for turbulent cases we have used three different gyro axis values: 0.083, 0.05 and 0.1, and for laminar case we have 0.35, and all these parameters are non-dimensional with the half channel height and the center streamline velocity for laminar flow. And here is the consultation plot for different cases, and this plot shows the consultation for all the horizontal cases when we have spherical particles injected with 0 velocity, and for these two lines are for the spherical particles, and we can see that the concentration for the spherical velocity is uniform across the channel, and this line shows the concentration of the channel for the ellipsoid particles, and this is the case, and we can see that it is not uniform across the channel, and these two lines are for the spherical and the ellipsoid particles when we have gyro axis, and we can see that particles are tending to move up and accumulating at the wall. And this is a concentration plot when we have the horizontal, vertical and the vertical channels when the gravity is in the direction of the fluid and against the direction of the fluid, and all the particles are injected have gyro axis, and as I said, these lines shows the particles are tending to move up for the horizontal cases, and this is when we have velocity gravity in the direction of the fluid, and we can see that it is uniform across the channel, and when we have gravity against the direction of fluid, particles are accumulating at the wall, as we can see here. And this was for the consultation of the streamers for the laminar cases, and here we can see that for electrolyte particles are accumulating at the wall, and this is taken at different time steps. And for the spherical particles are accumulating at 0.6 units below from the upper wall. And this is the initial position of our particles along the streamer's direction. Here we have a position versus time plot, and what we did, we took a particle at 1% and 99% when arranged according in the streamer's direction, and the area between these two lines occupied the 98% of the particles. And what we did, we convert the trailing and the leading edge velocity by the interpolation after first transit. And here I have some movies to show for the turbulent cases. When this is when the channel is vertical and the gravity is opposite to the direction of the fluid. And here we can see that particles are accumulating at the wall as we showed in the consultation part. And here we have the vertical channel when the gravity is in the direction of fluid. And we can see that particles are not accumulating at all this time. As we showed in the consultation part, particles are uniform across the channel. And this bar chart is for the velocity diversion for the turbulent case, and we have for these three plots are for the horizontal when we have spherical particles. This is for the left side, and this is for the vertical. For all the particles spherical, but for the first case we have velocity equal to 0 and without gyro axis, and for second case we inject the particles with some velocity which is equal to 0.02 and without the gyro axis. And here we have electrolyte particles. Those are spherical particles. Those have some gyro axis value, and we can see that we have maximum divergence for the fourth case. And here the values are the difference between the trailing and the leading edge velocities. And here the same chart, but this time we have electrolyte particles for the horizontal cases, and these are for the vertical cases. And we can see that the trend is almost same, but we have little bit more divergence for the electrolyte particles as compared to the spherical. And here we have also some movies, and the movies here are exactly matched with the experiment done by the John Kessler and presented in 1986. And he told that when we have particles, when we have gravity against the plate, the particles are going towards the wall, and when we have gravity in the direction of the plate, particles are coming towards the axis of the channel. And we can see in the this is the case when we have gravity against the plate, and this is the laminar case. And here, when we have gravity in the direction of the plate, all the particles coming towards the axis of the channel. And here we have laminar flow when the particles are spherical. This is for the horizontal channel, and this for the vertical channel. And here velocity in the y-axis, and with this when we have inject the spherical particles with some velocity, and the gyro axis value is 0.35, which is little bit large. And normally the gyro axis value should be around about 0.07. And we have maximum dispersion when we have gravity in the direction of the flow. It is also the comparison of same three channels, but the left side particle and trend is almost the same. And here we check the dependence of gyro axis on the velocity dispersion. And here we see that first when we have gyro axis is equal to 0.833, we have this much dispersion, and then when we decrease the gyro axis value, dispersion also decreases, and then we increase, dispersion increases, and so the dispersion increases with the increasing gyro axis value. Here are the ingredients. The concentration of the spherical particles across the channels is uniform, as we said in the plots. And for the left side particles, concentration is not uniform across the channel. And for the spherical and the left side particles with gyro axis, particles are accumulating at the wall and they are tending to move up. And for the laminar cases, we see that the spherical particles are accumulating at 0.6 units below from the upper wall, and for the left side particles, particles are accumulating at the wall. And we have maximum dispersion when we have velocity in fluid in the direction of the gravity. And we see that as I showed that we have little bit more dispersion when we have left side particles as compared to the spherical. And there are further suggestions that we can do further as Mansoor thesis. We can see the cell patterns, how they accumulate at the wall or how they affect the turbulence.